The chain rule then. Find the derivative of this function. We're going to focus on this function for an example and try and find the value when the time is 0.4 seconds. Here. I've plotted the function again, and so you can see it's quite a strange looking function, certainly at the start. So if we're focusing on 0.4 seconds, which is this bit here, what I'm trying to do when I do the differential is find the gradient of this function at this point. That's what we're after, the rate of change of the function, or the gradient at that point. So the rule itself, as we'll see, is not massively complicated. What's more awkward this time is deciding what to call u and what to call v. Not so straightforward. With the quotient rule, the one we've just been looking at, it's obvious usually. I've got 1 divided by another, and the product rule, 2 multiplied together. In this situation, I have one function inside another. So we need to consider, first of all, that we have got one function inside another, how we recognise that, and then what we do about it. If you look at this function, to find y, what I need to do, given the value for t, is to multiply, work out what 4t cubed minus 3t is. That's the first stage. And then when I've done that, raise that to the power 6. So there's two separate parts to it. So the chain rule is stated here. Again, here it is stated mathematically. What we do to apply it is we call one part of the function u and differentiate with respect to that u, and then multiply that by the differential of what u is. So that's what it says. Sounds awkward, but let's look at an example. We'll look at a few examples, and then you maybe see, actually, once you've got the hang of this, it's the easiest to apply. So what we do is, and I'll take you through this step by step. The first thing you do is identify that you've got one function inside another, because that means you need to use this chain rule. I've got this function, 4t cubed minus 3t, inside a power 6 function. So what I do is I let u equal 4t cubed minus 3t, the inside bit, if you like. So u equals 4t cubed minus 3t. Now, this is the bit that's different. What I do is I rewrite the original function, that's this function, I rewrite it, but instead of 4t cubed minus 3t, which I've called u, I replace that with u. So I write y equals u to the power 6. Now, I just differentiate each bit. If you look at that, if I differentiate with respect to u, I just use the rule where I bring the power down, times it by the number in front, which in this case is just 1, and take 1 off the power. So the differential of y with respect to u is just 6u to the 5. That's not difficult. And then I differentiate the inside bit, the bit that I've called u. Du by dt this time, because t is the independent variable. Bring the 3 down, times it by the 4 is 12, t squared. And the differential of 3t is just 3. So I end up with this. So I decide which bit I'm going to call u. Replace that inside the original function, so I rewrite it as y equals u to the 6. And then I differentiate that, but also differentiate the bit I've called u. Now the chain rule tells me, what do I do with that? I just multiply them together. The differential of the bit I've called u multiplied by the u, differential of u, tells me the differential of the function. So dy by dx, again, if you're doing this in your assignment, write down the chain rule. Dy by dt this time equals dy by du times du by dt. Make sure you're using your y's look different. So dy by dt, the differential I'm actually after, equals dy by du, which is 6u to the 5, multiplied by the differential of u, which is 2t squared minus 3. Finally, I'll replace u with what I said u was in the first place. What is u? It's 4t cubed minus 3t. So finally, 6 times 4t cubed minus 3t to the power 5 times 2t squared minus 3 is the final answer. Oh, 12, yeah. Thank you for pointing out that, Jack. 12 there, 12 there. So, 6, open bracket, 4, I can actually put 0.4 to the power 3, or cube, I've got a cube button there, minus 3 times 0.4, I can do 3 times 0.4, that's 1.2, all raised to the power 5, and then scrolling along, I times that by brackets 12 times 0.4 squared minus 3. And I get 4.86. The 3 significant figures. Check that for yourself and then see what you get.